Okay, so welcome to lecture number 7. So for this lecture, we will look at the properties of the document, and based on the properties, how do we form documents resemblance or document similarities. We're trying to compare document to document. And then after that, then we go to next session, which go to clustering, and then the next one will be classification. So this one will be the foundation for the next session. So the outline for today sharing will be, first we'll look at the metadata, the data about data that we have. So meaning that the data that we have will have their own information. We look into the document format. Different document will have different format. And then we will look at the text properties and then document pre-processing. So the document is considered as a single unit of information. Of course, they have syntax refer to meaning, and structure refer to the format of your document. So for example, textbooks, journals, they have different format and they have different content refer to different syntax. Okay, and when we talk about semantic, it refer to the meaning. Correction just now, the syntax referring to the structure also, the grammar of the document. Okay, and we have the sentence structure and so on. So semantic referring to meaning. So the concept they are talking about in the document. So each document or each journal will have their own presentation style. So given by its syntax and structure, so this is more on formatting, and we will look into how different document will have different syntax and different structure. So for example, the document syntax referring to the structure, they express the structure, how they present the style. At the same time, also this contribute to the semantic or the meaning of the document. Okay, so for example, this is your document, so it contains text and other media like images, sound. Sometimes for the slide, you can click on the button, it goes the video and also the sound and so on. Okay. So you have to provide format or structure for them to be arranged nicely. So nowadays they call one piece of no one page of information dashboard. Okay, and they have the presentation style, and then the structure and also the semantic. So semantic referring to the meaning. Okay, so one or more element might be implicit or given together. So you may have presentation style and structure together, or structure and semantic together, or all of them together in one document. Okay, so for the style, we define how a document is visualized or printed. So for different purpose, we'll have different format. Have you ever used text or MikTeX? So this is another tool that you can use just do scientific formatting of your document. So this is normally used by those people who are doing research in science and technology and engineering. so easy for formatting. Okay, like for example, this one tell you what is the structure for each chapter. So chapter 6 and then 6.1, and the font is different, and the text style are different. Okay. So for example, LaTeX section is used to show, you see the small text in the LaTeX, it's the blue section, and then label, and then the paragraph start. So, and also you see the 70% backslash and so on, and also the citation, the backslash site. Okay, so this is the formatting that they use for LaTeX. So it produces something like this. So if you look at the section, the introduction will be written like that because we use the section formatting. And this introduction section has a label called sec introduction. So next time when you want to refer to them, then you just refer to that particular section. So you notice that the 70%, the 33%, they only have the dollar sign up here. Okay. So this is the way we writing slash, because if you only write the percentage, it will mean like a comment. If you still remember in C they use slash this one, or no, in C++. In C they use this comment. So this is LaTeX, one of the tools used for scientific formatting. So the query in the search engine can be considered as a short piece of text because we write them in 2 or 3 words. So they are different from the normal text because the normal text consists of one sentence or more than one sentence. Okay? So we need to understand them because they are very important. For example, bank. So it could refer to Bank of River or bank account. So that's why we need to know how the term is being used with the context of the other word that we have. Then we know the meaning. So normally this one is studied in natural language processing, in which we learn how the word is being arranged in the sentence, and depends on the sequence of the word, they will know that this bank is referring to the Bank of River or bank account, depending on what word exists before or after the sentence. So it's simple to infer user intent behind a query, because when you type in the Google, they will try to predict what you want to type. So they will give you a list of suggestions for you to pick. So we look into the metadata. This is information about the information that we have. So metadata is the information on the organization of the data, how we organize them, and the various data domain and their relationship. Okay, if we refer to database, so we are looking at the structure of the database, how many column, what are the type of column we have, do they have primary key or composite key, to which table they are referring to, and so on. So we compare to a text document, so we are referring to who is the author, when did the document being published, source of publication, length of the document, and the topic or content of the text. So this one normally they want to differentiate the document or each of the paper that they have based on author, the date, publication, or even the title of the document. So last time we used this, I think they still use this one, but in digital format. Last time during my time, we still the chance to use this card. So we have to refer to the card. Why they use the card? Because it's easy to rearrange name according to the number, according to the place. So you will never miss that one unless if someone took out the card from the what we call it, the catalog card file. So they tell you what is the number. So each number will refer to certain meaning, like for this one, classification number, and then this one, physical description, and so on. So those librarian will know what code means what. So for us, we just want to know, is the book or is the document in place, or can we borrow the book or not? Sometimes they know that this book is not in the this library but located in the other library. So when we talk about semantic metadata, it's referred to the meaning or the concept or the content of your document. So they characterize the subject matter within the document content. So this is important because remember last time we want to do clustering. By clustering, we are grouping them into document consisting similar topics. So they are close to each other. So later on, we will use the clustering on how do we group them based on the content. So last time they used this machine readable cataloging record. They turn the card into more readable by the machine. So they look like this. So this is the anatomy of an AAS catalog record. So for each of the field or entity, they will have information. So when there are more information posted on the web due to the establishment of the World Wide Web, so the importance of cataloging or indexing the document become more important because more and more every day we will have more online resources. So some claim they own that document. So the IP rights and digital signature is getting more important because we want to know which document belong to us. We want to claim. Because if we just post the document and then someone can copy or can download and then modify, then it becomes theirs. How do we claim that document belong to us? So that become more important at the moment. So the first thing that we need to worry is how do we quantify or how do we some grouping them into topics or into cluster. And the second one is how do we enforce IP rights and digital signature into the document. And the third one is application of electronic commerce in which you can do trading or you can sell and buy the IP that you have for each of the document that you have. And one of the resources that they use, they call it resource description framework. So this is a new standard for web metadata in which you can on one page, you can tell who is the owner, and you can tell when did the web is being published. So they use this RDF to describe the. So this is to automate the um, processing, meaning that you know who is the owner, when was the website being created or published. RDF does not assume any particular application or semantic domain, so this is general. So normally they contain these two URL. We only know about the URL. So the URL starting from the HTTP until you see this up to here. When you try to retrieve some document, they have this also, hash key and other symbol. So that is what we call the URI, Uniform Resource. No, this is called Uniform Resource Name. So that is the name. Okay. So the URL is covering from HTTP until the name of the document. So the URI consists of both. So sometimes the name could be the URI could be long name. Okay, so a model for representing name properties and property value. So this RDF framework is used to representing the document. So normally we will have the object, resource, properties, and statement. So the resource will tell you what resource you have, and then what properties of the resources are you talking about, like who is the owner, and then the statement will tell you about the resource and the properties. This will give you some example. For example, like this, we have tuple representation. We have the predicate and subject and object. So for example, like this, we know that okay, this is the predicate, so this is the subject, and this is the object. So we know that okay, for the predicate it says the author. That means this is the author of this subject. So that's how we interpret the RDF. They give you three tuple representation. So this is like the role, and this is the subject. This is the object. So if we want to go further on this, we have to study what we call it semantic web. So semantic web use RDF to represent data in the web. So we will stop there just to give you an overview that also we are able to put some documentation. Who are the creator? Who are the when did the publish? So we say that okay, publish here, and we put publish here. That means here will be the date. So this is your subject. So this subject is being published on this date. So we can put more information about the subject. Okay. Now we go into information theory. So this is a very important part because it will tell you how important certain word that we have in the text. Okay. So for example, for a single symbol, how much information can be carried by that a single symbol. Okay. So, for example, this one they say that okay, It is difficult to formally capture how much information is there in a given text. Okay, so if the term is always used, it means they carry less meaning. So that's why like all the stop words, they carry less meaning. Okay, so however, the distribution of the symbol is related to it. So for example, like this, they appear more in the document. Okay, so this one carry less meaning. So in information theory, they define a special concept, what we call it entropy, to capture information content. So what is the formula for the entropy? So the entropy of the whole text, E, so this is, we assume that we have one term, and it consists of this symbol that we have. So they says that the entropy here referring to the probability of each of the term that we have here. So for example, no, yeah, this is the probability. So if you have high probability, that means 1, right? So what is log to 1? I double check. What is log is to 1? 0, right? So that means um, if the probability of each of the term is high, that means you entropy is 0. So when the entropy is 0 means they carry less meaning. So the value for this will be so n refer to the number of symbol that you have. So basically, you are taking the average of each of the term that you have here. So if we say this one, so the distribution of A is always high, maybe this one also always high. So when we add up this together, so the entropy will be low. Okay, so that means when your entropy is low, then you will carry less meaning. This is because the distribution of having them or the probability of having them is high. Okay, so for example, in a closed model, given this, so this is the probability of having all of U and I and so on, so on, so on. So this is based on 23 symbol that we have here. So when we use the formula here, so the entropy of the whole text for university will be this. Okay, so we take the U will be this one. Okay, the U will be this one over this, and then log 2. So we add up with uh, n, which is this one. Okay, so we add up all together, then we take the average. We have 10. We have 10 symbol here. So the entropy I didn't complete. Okay, so this is the total entropy that we have. So meaning that university carry this much of information. You know that the lower you carry less meaning, the higher you will carry more meaning. So that's how they look at how much information can be captured by single term. So when you study data mining, so they use the same formula here. So this is the formula that you study in data mining or advanced data mining last semester. So this is the entropy, where P is the probability of having that particular class um, in the domain that you have. Okay? So that's where they come from information theory. Okay, this is your exercise. So we can do it later. Okay, so just now I show you how to compute university. So now you will do it for Malaysia. So what you need to do is you just add up the log base 2 of the 1 over the probability of having each of the symbol that we have here, then divide by the number of symbol you have. Okay. Okay. Now we go into modeling natural language. So natural language referring to the normal language that we speak. So I call it natural language. So the symbol that we use for the Latin, we use symbol that separate the word, and we also use symbol that belong to words. Okay? So for example, even this example here. So we use the blank space in order to separate the word, and then we use this symbol to form the words. So they also talk about how are the different words distributed inside each document, because we know that certain words appear many times, certain words appear less. So they say that according to the zip law, it says the frequency of the uh, I most frequent word is given by this one. So where F1 is the frequency of the most frequent word, and this alpha is the text dependent parameter. So this is 1. So this is 1. And the second most frequent word has half number of occurrence of the first one. So if we have 2, and this is 2, and this is F1. So that means the second most frequent, so this is the second most frequent word has half number of occurrence of the first one. So divide by 2. Has half number of occurrence or less frequent because you divide by 2. So that means if you have 3, and this is your F1, divide by F2 again, and so on. So the meaning here is that the frequency of the word that you have may be going down for certain word that we have. This is the third most. Yeah, let me go back here. The formula will be like this. F2. Okay. So it says that third most frequent word has 1/3 number of occurrence. So imagine that you will have decreasing number of occurrence when you go to the next one, next one, next one, and so on. So based on this zip-load. So if we plot this one, we will have something like this. Okay, so the first important root will be here and then down, down. Because we have this formula, this is the I and then I, and then this is F1, right? So if 1, so you will have the most frequent. So if the second one will be uh, divided by 2, so you are down. So only a few would having high frequency. Let me erase this. And then we also have low frequency at the bottom. So it means that you can ignore half of the wood that you have. Or depending on the threshold that you set, you can ignore right side of the graph, wood that exists on your right hand side, because they are less frequent, and less frequent means they carry. Let me correct that one. You can ignore the word on your left, not on your right. Because more frequent means they are less important, they carry less meaning. Okay, so that's why when we have the stop word, they exist so many times in the text, so they are more frequent, so they carry less meaning. If they are more frequent, meaning they are carry less meaning. We also look at the text size. The text size here. So the V here referring to vocabulary. So if we are here, so that means the text size that we have here. What they want to show here is that this age, no, the vocabulary size goes sublinear with the text size. So that means, for example, if you say go and then goes and so on. So that one. Let me repeat that one. Erase this one. So over here refer to the number of different or the number of unique term that you have. So this one referring to the text size that you have. So they are saying that when you are allowed to have more symbol, then you have more vocabulary. But since we are in okay, in certain language, even if we add the text size, we cannot get more vocabulary because we have limited vocabulary. So our graph will like this. Okay, we have the size of text increase, but our vocabulary will stop there because we don't have that many vocabulary in our language. Okay, what is the long? This is just to play around with the English word. This is the longest English word that you have. So if you look at this one, so this is the longest word in the dictionary. I don't know how to pronounce them. So, like example, this is 45 letters. So this is a suppose tongue disease. We have 29 letters. This is the estimation of something as worthless. So if you want to say something which nobody understand, then you show this one. Okay. Okay, now we go into text similarity. So we understand about the format. We understand about each of the term that we have will carry different meaning or different level of uh, importance, significance, and so on. So now we look into text similarity. So um, we could there are a few methods on how we can measure the similarity between two terms. Okay, so for example, like this, the distance is 1 and the other one is 4. So this is what we call the Hamming distance. This is they count how many times you need to change. So this one um, include what number of terms that you need to change in order to map the other one. Or you could delete, or you could update, or you could insert. So the Hamming distance, they use number of operation that you need to do in order to make the similar. Okay, we also have the edit here. So this is similar to the previous one. So this one is referring to how many times also you need to substitute and so on. Delete. And this one, longest common subsequent, they look at what is the longest sequence of data that you could match between two survey and surgery. So we have 5. So we have 5 letters. That is the longest common subsequent letters. Okay, now we look at the similarity between documents. So this is between words. Okay, so next one is how do we look at the content of the document and we say that two documents are the same. So for example, like this is the um, set of all distinct words in document DJ. Okay, for the resemblance between two documents, we look at how many of them are common and divide by the number of unique terms that we have in both documents. So if they are the same, this one will be 1. Because if you do the intersection between these two, so you will have all the common term that you have. So if you do the union, if they are the same, you will only have either the first document or the second document, which is equivalent to the top one. So this is the formula that we use in order to compute the resemblance. We want to look at the differences, so we just take the 1 minus the resemblance. Let me show you some example here. So for example, this one we have document D1, D2, D3, D4. So these are the unique item that we have. We don't count the number of occurrence, but we look at unique item that we have. So if we want to find the resemblance between D1 and D2, so D1 and D2, so we are looking at the common one. So this one. So this is 2 over, so we have 2 common ones. So 3, 4, 5, 6, 7, 8, 9. So 2 over 9. So below one is the union of these two, and then the 2 is the common term that they are sharing. Let's take a look at D1 and D4. Let me erase first. Okay, D1 and D4. D1 and D4. So we're looking at this one. That one. So D1 and D4, we have 1, then 2, and just 2 only. So that's why we have 2. And then how many unique term in both? So we have 1. Initially we have B and D, 1, 2, then 3, 4, 5, 6, 7. So that's where is the 7. So because we have this formula D1 intersects with D4 divided by D1 union D4. So from here you can measure the distance. So the distance is basically finding the uh, resemblance first and then 1 minus the value. So the distance will be from D1 to D2 will be 1 minus 2 over 9, which is 7 over 9. So the rest will be the same. Okay. So having to know all these things, we also want to know what kind of document pre-processing that we need to do in order to process a document. So we have 5 operations. Okay, the first one is lexical analysis. Second one is elimination of stop words. Stemming of the remaining words where we take the root word only. And then selection of index terms of keyword. And then finally construction of the taxonomy or the thesaurus. Okay, that's okay, the first one is processing of converting stream of character into stream of word. So we want to perform the organization. We want to capture each term that we have in your document. So can detect the word separator like the space, the number, hyphens, punctuation mark. All this will not be in your list. So you only use them to perform the tokenization, which means you want to identify words in the document text that you have. And then the second one is you want to remove the stop words. You do not want to burden the CPU to compute all the TF-IDF for the stop word. Okay, and by eliminating the stop word, it can reduce the size of the index by 40%. Okay. This time also we can reduce the number of terms by finding the root. So for example, the connect here is the root word of connect here is the root word of connected, connecting, connection. So if these 3 words exist in your document, we count this connect 3 times to reduce the unique term that you have in your library. Okay. And keyword selection meaning that you sometimes you say, okay, only that keyword that exists at least 5 times. Then you reduce again the size of your vocabulary. So this is the full cycle of document pre-processing. So this is your document. You understand the text and the structure. By understanding the structure, you will be able to capture the the word that you have, and then you will perform the stop word removal. You identify noun word, you perform the stemming, and then lastly you put them into the library. So that is your taxonomic keyword that you have. Okay, very short one. So any question? One and Afif?
I'm okay.
Okay.
Yeah, enough time to finish the whole syllabus in lecture 7 before the last week.
When? When?
We have one more session, right, for this unit. The next 2 weeks. And then are we gonna cover all of them?
Actually, two more session. Text classification and text clustering. The clustering you study already. So we will do some short revision because I think we only have 2 weeks, including
Yeah.
next week, right? Next 2 weeks, kan? So
Yeah, next 2 weeks.
yeah, next 2 weeks. So we will cover 2 more session lah. 2 more session.
Okay.
So it's your exam. You know already?
January. January, I think.
Long time again.
What's the second week?
Second January.
Second week, 17.
Okay, yeah. So your exam got 4 questions, but mostly focus on retrieval evaluation one, and the second one is the relevant feedback, and then of course the classic model lah. And one will be surprise. So these 3 coming out lah. And of course this lah. But the next session your knowledge will be assessed through the assignment only, like the classification and also the clustering. 2 more session we have.
Yeah.
Then so midterm will be next week, next Thursday. So it will be 90 minutes. 90 minutes, 2 question only. So it cover until the retrieval evaluation, and also of course the classic model that we have, the FIDF lah.
Okay.
So anything that you want to ask?
The quiz will be open till Friday, right? The 2 quiz?
Yeah, I will reopen the quiz. For those who missed the quiz, you can take the quiz before Friday lah. I'll put
Thank
up,
you.
I think 2 more quizzes and 2 more assignments. But the most important part is your midterm, because midterm 20%, 20%, 50 marks. So that one can influence whether you can get A or. Okay.
Okay, thank you.
Good night and see you next Thursday lah kan.
See you. Thursday. See you next Thursday.
Yeah, most probably we'll meet again one more session before the midterm. We'll see first, because we need to cover 2 more sessions, right?
Yeah.
This week is second last or
second last, right? Should be.
second last kan. So
Yeah.
next week we will have
The
our
next session is not next week. Next 2 weeks is the last session. 2 weeks.
or next 2 weeks. Okay. So
Yeah.
okay lah. Next week we will have one session. Next week we will have another session. So okay lah. Okay. Night.
Okay. Thank you.
Rest
Thank you.
well.
Thank you.
Take care. Have fun in the retreat.
Thank you. Boring.